Okay, so why do we need this explicit lifetime here?
Can you scroll up to the struct definition?
Which struct?
So the reader struct. So the thing is that when we use structs, we want to have the structs own their data, and now here we are only storing a reference. And the problem which could occur that data we are referencing to dies before the struct dies, and then we would have a dangling reference, like we have reference to nowhere because the data died. And with this explicit lifetime, we make sure that the struct lives as long as the data we are referencing to.
But are we actually doing that? So we here in the pass function, right? So we give the pass function already a reference. So and then this comes from here, right? So how, like, okay, so basically what you're saying is that the struct dies when the data dies, or what? Because it can't really be the other way around, because like we are not making sure that the data is kept or something. Like I could probably do something like drop the data or something, like, right?
I'm not sure if you could drop the data, actually.
So here we have a reference to the data.
Yes.
Okay. Then we create the reader object. So I'm confused. So could I do something to the data here? Because I borrowed. Oh, it's not mutable. It's immutable, right? Yeah. So I can't do something with the data here. Except reading it.
No, you can't.
Yeah, I cannot destroy the data here. While the reader object lives. Interesting. Yeah, I'm still confused about this kind of thing. So
the letter A is actually doesn't matter, but in Rust you usually start with A and then go to B if you need to define it somewhere else. And this is like the thing you need to do when you have references inside any struct.
Okay. Yeah, I mean, kind of, sort of. I understand the theory, but I don't know how to create actually a dangling reference, even if I wanted to. Right. So just syntactically, how would I create a dangling reference? Right. That the compiler then can prevent me from doing so.
If you would have asked not mutable,
like, yeah.
Wait.
Yeah. I mean, it's not mutable anyway. Only the reader is mutable. Oh. I mean, this is what we are constantly changing, right?
Yes.
Oh, okay, yeah. Now I get it. Yeah. this slice isn't actually the same slice in every call here. It's always different because here there's this thing. Okay. Yeah. So that's why we have to make sure. Okay. Yeah. Well. Okay. I mean, I don't know if I would have like come up with this without compiler warnings or errors. Yeah. Like I pretty sure I wouldn't have like come up with adding the lifetime if not for the compiler making me do this. Right? So I not fully like understood it, but yeah. I mean, this code is like okay, pretty trivial to me. Yeah, but yeah, okay.
It's also explained in chapter 5 and chapter 10 of the Rust book. If you want to read it up.
Yeah, I read it, but still, it's kind of weird. Yeah. Okay. Okay. Yeah. Anyway, so let's continue with improving the code. So right now, our code is basically just handling inside, like has a main loop and handles only the game controller.
Yes.
But it doesn't do anything else useful, right? And we only have like one main file, so we kind of don't like really like want this like this. We want to make the code a little bit more modular. So so what we like, we have this kind of thing in our C++ code that we basically have a folder called modules, and then we have a folder called representations. Okay, and yeah, for example, we could have like a representation is usually like in our C++ code, it's just a class that holds data. So, and for example, kind of some data that we need, we could call this ball percept. So what do we do here? So we have the struct ball percept, right? So, and let's call it x, and this is just a floating point value, and with a y value. So, okay. This is just a struct, right? Okay.
Yep.
And what we like usually in our code mean with ball percept is a position in the image.
Okay.
So this would be like just a pixel coordinate in that sense. So yeah, and so we discussed this kind of macro stuff last time, I think, right?
Yep.
So we can say it can have a default values, and we want to be able to print it with a print macro. So we add the debug thing here. So yeah, so we could create representations similar to this. Okay.
Yep.
So I prepared a little bit, like just to show the structure. So So frame ID, and that's this, and yeah, let's have more. So we also need the robot pose, right? And that would be something struct pose, right? And that would again be floating point value. So and center. As I mean, it doesn't really matter how we name it right now, right?
What does robot pose actually mean? Like when the robot thinks appears, or?
Yes. I mean, like, first of all, this is just sort of a container that holds data. So,
okay.
So it can hold 3 floating point values. So the meaning comes of like, how do you want to use it? So this would be the position the robot thinks it is on the field. So you have an idea of what is the coordinate system of the soccer field. And usually we do it, the origin of the coordinate system is the center of the field.
Okay.
And the angle 0 is looking towards the opponent goal. Yeah.
Yep.
And then the coordinate system follows the right hand rule. So positive y is the left side. Yeah.
Yep.
So this is what it means. Usually, like in physics, in your physics class, you should have like talked about left-hand and right-hand rule kind of thing.
Probably.
Yeah. So it just means where is the positive, like in which direction is the positive value.
Yep.
So x is forward, basically. Y
Yep.
is left or right, but then the question is what is positive y, what is negative y? Is it left or right?
And we do right.
Yeah, left. Left is positive, so right hand rule. Because if you use your right hand, then your middle finger points to the left side. This kind of position. And Z would be up if you like want to have elevation. So, but we don't really care about this. Okay. So, then we also want the game control data, right? So we don't want to, like, currently we have structs in the main file, right?
Yes.
But this is not really what we want. So, so we want to change this. So we move this over here, and then also the team info goes here, and then the robot game control data also goes here, right? So all we did is move the files. So obviously the code now doesn't compile because we don't include it here, right? So it wouldn't find this. Okay, so we have to do this later. Okay. Then so we have to do this, I think, like this. Once again, I was way too lazy to actually look it up. But you have to do kind of, so mod, it also kind of means module, but this is like not the modules we are talking about in our organization of the code. So, but basically it means here is a folder representations, right? What we want to use. So, and so we have to declare this and then do that. So from representations we want to use those structs or things. Okay?
Yep.
So This also won't compile because in the representations folder we need to do this thing, and yeah, we need to export this kind of stuff so we can import it from the representations, basically. So this is similar to what you're doing with an initpy in Python.
In Python,
yeah. So when you have like Python modules, and so to save us in the main file some typing, we re-export this, right? So otherwise we would have to write ball.percept : ball.percept.
Oh, okay.
This is a file name, this is a struct name, right? Yeah.
Yep.
So yeah.
But all structs need to be public, or whatever pub means.
Yeah, and like this will also not compile. So because we need to make it public, so we can export it. So this won't also work. Like if we would use ball.percept, we would need to use then we can only access x and y if it's also public, right? So all of this needs to be public as well. Yep. And here I already did this. Yeah. So. And I don't know how much stuff I forgot. Oh. But maybe it compiles. Like there's a chance. Let's see. No. So we have a lot of errors somehow. Okay.
It's because of the reader.
Yeah. So yeah. How to actually do this correctly? Yeah. What?
We need to import team info and robot info.
You. No. So. Lots of warnings because we don't use any of it, but yeah. Is it running? Yeah. Yeah, probably it doesn't do anything if the game controller is not running. Yeah.
Now it's doing something.
Okay, so now it kind of looks a bit better, right? So, and the code now is a little bit cleaner. It's still not clean, right? So,
no.
But and we are not using any of the other representation. This is just like how you would build representations. Yeah, let's stop this for now. Now we could go to actually building. Like right now the implementation of the game controller is still directly here. So we could build something like a module game controller. Okay.
Game controller listener, or
just I mean like I would just call it game controller for now. Yeah. You can totally refactor this at a later stage. So yeah, and basically everything that we need here, so that goes here, right? Don't want this in the main file. The whole reader stuff, right, goes here. And then now we want to build something that we can actually use. So I prepared this kind of thing. So we have just a struct game controller handler, so it gets a UDP socket, a buffer. So so this will be important later on. So that you initialize the game controller once, right? And then you run a function in a loop. So here we initialize buffer once, and then it like reuse it in every loop iteration, right? So
yes.
So that why the class basically needs to own the buffer, right? And then we would implement a function for this game controller handler, right? So, and what do we need to put in here, right? So
listen, or
so basically, like, we don't really need this anymore, I think. Game controller. So so here we have this. So I'm just copying or moving this function here, right?
Okay.
So yeah, the game controller handler can pass a message, right? And then we don't need this implementation for the data. So, but this also means that the pass function doesn't return something from the game controller handler.
Yeah.
It returns something else, namely game control data.
Yep.
So this is basically just a small little refactoring. So nothing really groundbreaking. So, but we need a constructor. So right? The constructor takes team number.
Yes.
And player number. So far so good?
Yeah, I would say this is sufficient.
So what should it return? Well,
game controller handler.
Yeah, self basically.
Oh, or self.
I think you write it something like this. Okay. And let me just do this. Okay. Sort of. Okay. So is this correct? No. So then we need something else that we really didn't care about it before. So you know that the game controller sends messages at a fixed rate. Okay?
Yes.
So, and since we are not doing anything else here in our main, right? We don't really see it that this function here waits till it gets a full message. So this thing will wait till it gets a message, which is 2 times a second. So the loop is not running as fast as it could. Okay?
Okay.
So because the socket will just wait till it gets data. So we need to set it to non-blocking. Okay.
Okay.
So
we can always read.
Yeah, I mean, if there's new data, it will put it into the buffer, right? But if not, then that's fine. Okay. So and the last line in the function is always what you return. So we return this, and I think then you need to like wrap it in a result kind of thing.
Yep.
Something like this, I think. So similar to the option. Yeah. Yeah. But also, since we do it here, we don't need like to actually do this, right? So this kind of works. So now we have a more independent game controller. Okay.
Yes.
So
but it's the logic of running the game controller is inside the main.
Yeah. So here now the folder structure comes a little bit more important. So here we did like use representations, okay? Representations, because we are in the main file, and there's a folder representations. Okay. So we can't really do this if we are in folder modules, because there's no subfolder representations in modules. So we go from the create. So this is everything in source, and then representations, and then we include the data.
Yeah.
Okay. So maybe that works. I have no idea. It could work. So, but we also need to actually use this, right? So right now we just created a module that we are not use at the moment.
We need to import it.
New. And then do this kind of like this. So, but this won't work. Why? What we are missing in the modules folder? There's something missing.
We are missing the mod .rs file.
So, and it's basically similar to what we did before, and just so we have to write less in the main file. We do it like this. Okay, and we haven't implemented this yet, so we just do it like this.
Maybe the constructor needs to be public as well of the game controller handler implementation.
Yeah. And I'm just seeing that we need to put this here, the standard I/O stuff. What needs to be public?
The constructor.
Yes, that's a good point. Otherwise, we couldn't call it. Yep.
Would be pointless to import it.
Yeah. So controller handler. Yeah. I mean, we just couldn't. Like, we can have private functions, but it's kind of not really useful to have a private constructor.
Not really.
Yeah. So. Yeah. So now you wanna create an instance of this module, like module in quotes, like it's just a class, right?
Yep.
So, well, it should be mutable, so call it anything we want, and game controller handler, right? So, and we want to call the new function, so the constructor, and it gives the team number and a player number. Okay.
Why are we making it mutable?
Mutable? The GC handler?
Yes.
Because the buffer of the game controller handler will change.
Okay. Yeah, that makes sense. Yeah.
Right. So. So, and so I need to cheat a little bit and check what we need to do. So here we have like a function pass, right? So, but yeah. On a kind of this is just a pass function, right? So this function, this is what we actually want to do, right?
Yep.
So we create a new function here. So obviously public function, and similar to what we do in C++, we call it execute. So this is sort of the function you would usually call, except the constructor from outside. And all the other, so technically then the pass function doesn't need to be public, because only the execute will call this. Okay?
Yep.
So what's the return? Can you guess?
Result RoboCup game control data.
Yeah. 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 No. The execute method will not return the RoboCup game control data. It will actually like not return anything.
Okay.
Yeah. So. Okay. So. Okay. So now something like a new construct. Okay. So here, if we get some data or pass some data, or no here. So we earlier we waited for data from the socket. Okay.
Yes.
So this is what here, and then we get number of bytes that we read from the socket and these socket address. Okay. Since we want to do this non-blocking, we have to like do this a little bit differently. So, so and then in Rust you usually do this like with the match kind of thing. So it has two cases, right? Or actually three. So if we get something, then we return the result, which would be this.
Yep.
Yeah. Yeah. So. Yeah, I looked this up. Yeah. So here we return just okay. So but no data. So we don't return an error. Like we don't crash.
Okay.
Yeah.
So this would run if we got no data.
Yeah. Yeah.
Okay.
Yeah. So, but then we return early, right? So.
Yep.
We don't get to this point here. Okay. So what do we need to do here? Well, same thing as this, right? So
yep.
Because at this point here, we actually have data. So then we want to do something. Okay. So, but and now we can like add different conditions, right? So to do, could actually check for check for valid data or something like this, right? So we could, for example, check did we get the right game controller header? Did we get the right version or whatever, right? So
yes.
So but actually, like in one sense, like it doesn't really matter, right? Because it wouldn't, the parse function wouldn't work.
Yeah. So the parse function would return an error anyways.
Yeah.
If data is not valid.
Yeah. Also, this is wrong. We need to call this. Yeah, this parse function because we moved it to this game controller handler.
Yep.
Yeah. And by the way, the execute function needs to take some stuff. So it gets a reference to self and the game controller. Or the data, actually. Sorry, not the game controller. So it needs to be here. So we give it a reference to where it should actually write the data. So
yep.
So okay. We could then do the print line stuff, yeah, again, if you want to, and then just send the stuff. Okay.
We could also make like the sending stuff another function.
Yeah. We could absolutely improve this, right? And later on we will, because now we want to like actually send data, like valid data, like ball detection stuff and robot pose stuff and so on. Yeah. But yeah, and kinda need to return something because this is what Rust expects. No. So if he reaches blocks, then it's probably okay. Yeah, if he get out of this block, if block here. No. So let's see how many mistakes we made. Yeah. Absolutely. We need to. Yeah, this of course doesn't work anymore. We need to actually call the correct data, right? So. And this doesn't work, so it needs to be self.socket. And this is also
self
buffer. Probably. And we need to fix this, I think. Yeah. This doesn't work? Okay.
It's team in the constructor, but team num in the return statement.
What? Wait, well, team num.
In the function signature, like line 82.
Oh, yeah. Yay. Yeah, so many mistakes, right? This one is in the main. But yeah, so
you could install like the Rust Analyzer extension to highlight winter errors.
Yeah, probably. So like we can run it, but it doesn't do anything. We have a busy loop that doesn't like do nothing, right? So now, what should we put in the loop? So what should I write here?
gc handler.execute.
Yo.
But we need to give it some place to store the data.
Yep.
So we need to initialize a new RoboCup control data object, struct.
I mean, I think, yeah, we can do this like let a equals RoboCup. So, and would this work?
It should be mutable.
Yes, exactly. And also
need to pass reference.
Yeah. Yep. So this could work, right? Maybe?
I don't think that the syntax of the struct is correct in line 13.
Okay.
This could work.
Let's see. It doesn't. What are you doing? Did we give it a defaulting? No. I think it needs to be like this. Why doesn't find it? I'm confused.
You need to put a question mark in line 12. At the end.
Oh, right. Yeah.
To make the arrow macro work, right?
Yeah. Now it works.
Hey.
So let's change the state. So yeah, absolutely works. Oh, stop play, finish. And so. Okay, so this is how you would do like module architecture, sort of. So
at least part of it.
Yeah, I mean, this is how you can structure code. Now you can create other modules, like things that do something like a ball detection or self-localization or whatever, right? And you would like do it similar to this, right?
Yep. Yeah. You initialize it and then let it run in a loop.
Yeah. So
that's why it was so important that the socket listener was not blocking.
Yeah. So, and like we could have like struct and you call it blackboard something, right? And then we would do it like this. Okay. And then here we would create also create like sort of state, also blackboard. I don't know how to call it. So, and then you would call it. So here you would then use state GC data, right? So, and then you don't need this line here. So, initialize the blackboard, right? And here you would to do at a rest of representations here, right? And then here you can give every module a reference to the data it should work on, right? And then you decide here basically which module can modify which data by either making it mutable or not, right?
And if you put a non-mutable reference, it could only read.
Yeah, but then also you would need to make sure that the game controller, right? So, but this is what you do like as developer anyway. You decide which modules should modify which data. It's not in that sense dynamic, right? So the ball detection module should not modify the robot pose, for example.
Yep.
Right, but maybe it reads it for some reason. And then you would make sure that the constructor or the execute function only gets the data it needs, right? Not the constructor.
So with this kind of architecture, it wouldn't be possible that we have two modules writing the same data.
No, like then that would be a compile error.
Yeah. Okay, but we probably don't actually need to do this.
No.
We could just have another struct inside the blackboard. We just have another new data type inside the blackboard if you have more modules writing data.
Yeah. I mean, so the blackboard just the game controller data, but only the game controller handler should write this anyway. So, yeah. But basically, like right now we're doing like no parallelism here, right? So if we would make it multi-threaded, then we can also make sure that any module that needs to read the game controller data, for example behavior, should need like to know which state you're in, right?
Yep.
Then it cannot run in parallel. You cannot write and read at the same time.
Yep.
Right. So for example, like something like this smooth image, right? Oh no, it's a reference to image, right? And mute. What did you call it?
Ball percept.
No. So something like this.
Yep.
And so on, right? But so now, like with this code, you can sort of type out how do you want to struct, like what kind of modules do you have, right? You can just imagine what do you need, and then you can write the bare bones thing without actually implementing everything. But then you have like the structure of the whole code already. Okay.
That's an achievement. Yep.
So, and so then, so everything that needs to get some data from the robot, like, would need to also, like, you would like use a crate, so booster SDK or something, and then call specific functions from it in the implementation. But here, this loop basically would just get more of this in the correct order. Does that make sense?
Yep.
And also you would need to implement some method that it runs at a specific frequency. So, for example, you would measure the time it takes to do one iteration, right? And then rate the difference to whatever your frequency is, right?
Yep.
So if you want to like run this like in 33 milliseconds, and then your code is faster, then you rate the rest of it, right?
Yep.
This. But yeah, so this is what we mean with module architecture or blackboard architecture in our sense. So this is all there is to it. So, and so this is kind of secret, right? That we have this state that exists for the whole duration while the robot is on.
Yep.
And all the modules just change the state. But which state they change, well, depends on like how you implement this, right? So technically every module, like every code here, can modify all of the blackboard. But by convention, we have it done, like we make sure that it's very explicit which kind of data you modify and which not. Right? But I technically could write any code here that modifies like anything on the blackboard, because here this variable is mutable. So code after this can just modify it. Yeah.
Are you sure that this would compile if we passed like the mutable reference to GC data?
Huh? I mean, it runs right now.
Yeah, but if you have like another line of code trying to modify it.
Well, this is done, and then you can change it again. You don't do this like it's a loop. It's not parallel. You cannot do it at the same time.
Oh, yeah. Now I understand it.
I mean, I can just do this. Okay. This doesn't work. That doesn't work.
The trait is not implemented for Blackboard, the default trait.
Oh, yeah.
You need to copy it from...
Yeah, forgot this. And this is also... Oh. Okay, but in essence, typos, right? But here, just code twice, right? So
yeah.
Absolutely.
I was just confused.
Yeah. So, and then, so logging, right? Just call logging module and give it a reference to the state.
Yep.
And then it can just like read everything from here the blackboard and write it to a file or whatever. Right?
Yes.
So, and this would be like always the last thing you do. Okay.
Yeah, because you need all data in the loop to
usually
write it down.
That's what you want. I mean, yeah. Right.
Yep.
But yeah, so this is the structure of like the whole thing, like how you do it. So what, like when you look at the Hulks code, so they don't do this exactly like we right now. For them, every kind of thing like the ball percept module like something that detects the ball, is its own Rust crate. So then the folder structure and everything looks a little bit different.
Okay.
Yeah, but yeah, so there are many different options on like what you can actually do, right? But yeah.
I mean, this seems to work.
Yeah. Yeah. So I mean, this is the importing thing could look a little bit nicer if you do it with crates, but then you have more files. Then you, for example, then you have a cargo toml and everything for every crate. You just shift the complexity to somewhere else. Yeah. 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 So this is it.
Nice.
Okay. I think next time we can like implement all the other modules and like have them generate some dummy data, and then like have a look at how we would do some logging, right?
Would be interesting, yes.
So, okay, see you next time.